In this video, we're going to talk about area between polar curves. Let's say you want to find the area of this blue shaded region. How can you find the area of this shaded region over here? In order to do that, we have to find the area of this whole thing over here and then subtract the area of this region, so that we only get the area of the shaded region. In other words, 1/2 times the integral from alpha to beta R2 square d theta would give you this whole area of this whole region over here. And 1/2 times the integral from alpha to beta R1 square d theta would give you the area of this region over here. So when you subtract, you get the area of this shaded region. And when you combine these, you will get 1/2 times the integral from alpha to beta, quantity R2 square minus R1 square, and d theta. So here R2 is the longer radius and R1 is the smaller radius. So the area of the region between R1 theta and R2 theta for alpha to beta will be this right here, what we just talked about. And remember, in this case, R2 is longer radius and R1 is the shorter radius. So let's take a look at example. It says find the area of the region that lies inside the circle R equals 1 and outside the cardioid R equals 1 minus cosine theta. So let's graph this and see which region they're talking about. So I'm going to put my R1 as 1 and R2 as 1 minus cosine theta. Now, this does not mean automatically that R2, which is 1 minus cosine theta, is the longer radius. We have to double check by looking at the graphs. So let's graph this. So let's go to zoom, standard. And let's go to zoom, fit for 0, and zoom square. So you get a nice graph like this. Now remember, let's go back to y equals. Our blue line is r equals 1, and red is r equals 1 minus cosine theta. So here's our circle, r equals 1. And here is 1 minus cosine theta. So they want us to find the area that is inside the circle, but outside this cardioid, which means that we got to find the area of this right here. This is the area that we need to find. Now notice, if we somehow find the area of this, and since they're symmetrical, we could double the area and get the total area that we want. Now, so in order to do that, we got to find alpha and beta. And we know that the r equals 1 is the longer radius, and r equals 1 minus cosine theta is the shorter radius. Now, how do we get from here to here? Well, looking at from theta, it looks like we're going from 0 to pi over 2. So let's just graph 0 to pi over 2 and see if we get the graph that we want. So we're going to go to window, and let's go to 0 to pi over 2. And that's exactly the graph that we wanted. So we got our alpha and we got beta. Alpha is 0 and beta is pi over 2. And again, our longer radius will be r equals 1, and our shorter radius is r equals 1 minus cosine theta. So based on this information, now we could have a setup to find the area that we want. So it will be 1 over 2 integral from 0 to pi over 2, 1 square minus quantity 1 minus cosine theta square, and that whole thing times d theta. But remember, we have to multiply that by 2 to get the area that we were looking for. So 2 and 1 over 2 cancels out. So all we got to do is use our calculator to evaluate this. And remember, our R1 was 1 and R2 was 1 minus cosine theta. So use math, function integral. We're going from 0 to pi over 2. It's going to be R1 square minus R2 square, and then d theta. Press enter, and there is your answer, 1.2146. So 1.2146 is the area that we were looking for.